Hey, this is Adrian from PiImageSearch.com, and today I'm going to show you how to install OpenCV 3 on your Raspberry Pi, specifically using the Raspbian Jessie operating system. So you're already viewing this blog post, and I'm sure you've seen the step-by-step tutorial to show you how to get OpenCV 3 installed on your Pi. But what I'm going to do here is walk you through it step by step, working through each command. That way we can install OpenCV together and we don't get lost in the details. So with that said, let's get to work. I'm going to fire up a terminal and I'm going to SSH into my Pi. You could, of course, hook up a keyboard, mouse, monitor to your Pi and do it that way. But for me, I just prefer to use SSH because I think it's a little easier. But again, do whatever works for you. Enter my IP address of the Raspberry Pi and log in. All right, so I'm logged in. The first thing I want to do here is go through and update the package definitions for the Raspberry Pi. So this will sit here for a couple seconds and do its thing. Again, it shouldn't take too long, but I'll catch up with you once this command is finished running. All right, so the update command is finished running. Now let's go ahead and upgrade any existing packages installed on our Pi. This should take a little bit while longer to download. You may have to hit the Y key indicating yes, I would like to perform the operation. Again, this might take a little bit longer than the actual update itself since we're actually at this point downloading and installing any upgrades. So I will catch up with you again once this command is done. So the last step here is optional, and all it does is perform a firmware upgrade on the Raspberry Pi. Again, this is completely and totally optional for getting OpenCV installed. I just prefer to, when I'm installing and setting up a Raspberry Pi for the first time, just to get it 100% set up, upgraded, updated, and ready to go. This will require a reboot after we're finished, and it will take some time to go ahead and download everything and install the firmware update. So I will catch up with you again once we have finished downloading the Raspberry Pi update and installing it. So our Raspberry Pi update finished okay. So we need to reboot it to make the changes take effect. It's very simple. Sudo reboot will take care of that, and that'll automatically trigger the Raspberry Pi to shut down and restart itself. As you can see, it's immediately closed my SSH connection, but no worries, once it comes back online, I'll be able to log back in without a problem. So after the Raspberry Pi has rebooted, SSH should be up and running again. Sure enough, it is. So we're going to go ahead and install some developer tools. This should take approximately 1 to 2 minutes to do. Not a very long time at all. In fact, some of these packages, such as Build Essential and Package Config, are likely already installed, but it's good just to include them in the apt-get statement just in case that they aren't. So we'll let these packages go ahead and finish downloading and installing, and when it finishes up, I will catch up with you at installing the image IO packages. Okay, so now we can install our image input-output packages. Copy and paste the command into here, and this will handle basically installing all these packages related to reading various image file formats from disk, such as JPEG, PNG, TIFF images, etc. This is a very important step that you want to take. If you miss this step, you won't be able to load various file formats from disk, and it'll be very hard to debug because you won't actually get errors from the cv2.im read function. They'll just return none, and you'll be quite confused, wondering why your image isn't loading. In all likelihood, it's likely because you didn't install these image IO packages. And just like we have image IO packages, we also have video IO packages, and these allow us to read various video file formats from disk. So I'm just going to copy and paste the command in here, select yes. I want to perform the operation and download the extra packages. So we'll let the Pi sit here for a few seconds and do its thing before we run the second command. Okay, so the first command finished up. Let's run this one as well. Copy and paste it in there, and I will catch up with you again once the Pi has finished installing. Cool, so that finished up okay. We can now move on to installing GTK. GTK is a library that handles creating various GUI-based applications. In the case of OpenCV, it's a very specific submodule called HiGUI that allows you to construct GUIs, display images to your screen, as well as perform various operations like constructing buttons and sliders. These GUI operations really aren't that advanced, but they are needed so we can visually see our images. This is useful for displaying output and even more useful for actually debugging our applications. So I'm gonna let this run. As you can see, it's gonna take approximately 3 minutes to finish installing, and I'll catch up with you then. Welcome back. Looks like GTK has finished installing, so we'll move on to our next set of commands here. We're gonna install libatlas, which is a library used to handle some optimizations within OpenCV. Again, this is starting to feel a little repetitive to you by now. You're just copy and pasting commands in the command line and letting them run. But that's the way this tutorial is designed. It's supposed to help you get everything up and running as quickly as possible while just giving the basics of what you need to understand. So we'll let this run, and when it's finished up, I'll catch back up with you. Moving right along, let's install our Python 2.7 and Python 3 development headers. These files are used so we can compile our OpenCV bindings against our appropriate Python version. Without them, we would not be able to have our Python bindings and be able to access OpenCV from the Python programming language. This will be the last step we have to run in step number 1, and then we can move into step number 2, where we actually grab the OpenCV source code from GitHub. So I will check back in with you once our development headers have been installed. So here we go. Step 2 of installing OpenCV 3 on the Raspberry Pi for the Raspbian Jessie operating system. First command we need to run is cd tilde, and all this is doing is changing directory back to our home directory. I'm in our home directory already, so there's no change in output. And I'm going to grab the 3.0.0 version of OpenCV and let it download to a file named opencv.zip. Now, in future versions of OpenCV 3, we may have 3.1 or 3.2 or 3.3.3. In either case, no worries, you can continue to follow this tutorial. Just come down here to the wget command and you would change it to the appropriate version and let it download. So let's see, there's about 80 seconds left in this download. Let it finish up, and then once it's done, we're gonna unzip it. So I will see you then. So now that download is completed, you should see an opencv.zip file in your current working directory. We're gonna go ahead and inflate that to a directory called opencv-3.0.0. This will contain our actual OpenCV source code that we'll be compiling. However, there's another package we need to pull down. It's called the OpenCV contrib module, and this contains modules that OpenCV calls non-free. Non-free probably isn't the best way to describe these packages. It's not that you have to pay money to use them. It just means that they are copyrighted in some form or another. Popular algorithms such as SIFT and SURF, which are actually part of OpenCV 2.4 by default, have been removed in OpenCV 3.0 and put into this contrib package. However, SIFT and SURF are used so much in computer vision within OpenCV. I personally don't think it makes sense to install OpenCV without the extra contrib packages. So once we're done inflating the OpenCV directory, we're going to go ahead and download the contrib package as well. So once this is done, I'll catch back up with you. All right, so we're done expanding the OpenCV archive. Let's grab the contrib archive as well. I'm just gonna copy and paste the wget command into here and let this download. Should take about 2 minutes. So once it's done, I'll catch back up with you and we'll unzip it as well. So the contrib package has finished downloading, and we can see that by looking at the OpenCV underscore contrib.zip file and our working path, and go ahead and unzip it in the same way as we did with the opencv.zip file. Once this is finished up, we can finally move on to step 3, which is setting up Python so we can compile our OpenCV bindings. First thing we're going to do is run wget to grab pip. Pip is a package manager for Python. Makes our lives a lot easier when installing and managing packages for various Python versions. So wget is going to grab the get pip file, and then we can just run sudo python get pip.py. This will handle the actual installation of pip on our system. So I've talked a lot about virtual env and virtual env wrapper a lot on the PyImageSearch blog, and I'm not going to go into huge detail about it again. However, it's pretty much standard practice in the Python community to use virtual env and virtual env wrapper for managing your Python installations and your Python environments. So like all good Python developers, we're going to go ahead and use it as well. So I'm just going to copy and paste this pip command to install virtual env and virtual env wrapper. We'll let that run for a couple seconds, and once it's done downloading and installing, we actually want to use this command here and blow away the .cache/pip directory. And that's because we want to be able to run pip as the Py user. However, by running it as sudo, as we've done up here, we've actually created some files within the .cache directory that may not be directly overwritable by the standard user. So it's good just to kind of delete this entire directory and be done with it. Now, this next part is where a lot of readers get tripped up. We'll need to update our home .profile file. And you may be wondering, what is that? Well, I'm going to just do an ls. I'm going to list the hidden directory here, or the hidden files in the current directory. And you'll see this .profile file right here. This file is theoretically loaded every time we open up terminal or log in, or we have to manually source it, as we'll see later. But the point is we have to edit this file. Now, how do you edit it? Well, you could edit it using Nano. You could edit it using VI, Emacs. If you're working with your Raspberry Pi connected to a monitor or over VNC, you could use your standard GUI text editor. I'm just going to use Nano because it's an easy text editor, especially if you're first getting started. So now I have the .profile file opened, and I'm going to scroll down to the bottom, and I'm going to copy and paste the following lines into the bottom of the file. It's just going to allow us to access virtual env and virtual env wrapper as we need it. I'll press Control X to exit, and I'll say, do you want to save your changes? I'll say yes. And what do you want to name the file? I want to keep it named .profile. I'll hit enter, and I'm done. That's it. Now we need to reload the changes to our .profile file. Just copy and paste source .profile, and there we go. We'll see that virtual env wrapper is creating some commands for us, which we're actually going to leverage right now. Let's create our first virtual environment. Make virtual env CV. I'm calling this virtual environment CV. You could call it, whatever you wanted to. I think CV is very descriptive of a virtual environment that's going to handle computer vision processing. You'll notice that this command is going to create my my CD virtual environment with the Python 2.7 version. However, if you do not want to use Python 2.7, just append -p Python 3, and that'll create a Python 3 virtual environment for you. Again, that's entirely dependent on how you want to set up your system. I'm going to go ahead and use Python 2.7 for this demonstration. Now, let's say you log out of your Pi, you reboot your Pi, you have a power failure, whatever it is. During the middle of this tutorial, you just lose access to your Pi and you're logged out. How are you supposed to continue working on it? Well, the way you're supposed to continue using this tutorial is you log back into your Pi. You want to load the contents of your .profile into your current environment. So we'll use the source command, and then finally I can run work on CV, and this will drop me into my virtual environment, and I can continue my work. We're going to move on to installing NumPy, which is an important dependency for installing OpenCV with Python bindings. I'm going to copy and paste pip install NumPy. That's going to take care of all the hard work for us. Now, as you'll notice, installing NumPy can take a good 16 to 20 minutes. So I'm going to let this run, and once it's finished up, I'll catch up with you at step number 4, where we actually compile and install OpenCV. I'll see you there. So NumPy just finished installing, and we can move on to step number 4, where we actually compile and install OpenCV. The first thing you want to do is make sure you're in the CV virtual environment. As you can see from my prompt, I already am. If you're not, just type in work on CV and that'll take care of it. From there, let's set up our build directory. We're going to change the home directory /OpenCV 3.0.0. And we're going to make a directory called build. This is going to actually store the compilation, our build of OpenCV, and change into the build directory. Now we're going to let CMake configure the build for us. All you got to do is copy and paste this command into here and hit enter. And this will kick off the actual configuration step where it detects what libraries and dependencies we actually have installed and which ones we don't. This is also where the Python bindings are configured. And I will tell you a little bit more about that once CMake is finished running. Okay, so CMake just finished running, and let's take a look at the Python 2.7 section. It should look something like this, highlighted in red. That'll be the output from CMake. So I'm going to scroll up here. I want to check the interpreter and the NumPy setting. As I can see from the interpreter, it's going to use the CV virtual environment, and specifically the Python 2.7 binary within the CV virtual environment. And the same thing goes for NumPy. We're going to be using the NumPy version 1.10.1 also installed in the virtual environment called CV. If you do not see the CV virtual environment in the output of the Python 2.7 section, then it's likely that you did not run this CMake command within the CV virtual environment. So make sure you go back, type in work on CV, and then rerun CMake to make sure that your development environment has been configured properly and that CMake is going to build against a correct version of Python. So now that we're done running CMake, the last step we have to do is actually build OpenCV. We'll do that by typing in make-j4, where the 4 stands for the number of cores we're going to use. Since we're on the Raspberry Pi 2, we can use up to the 4 available cores on the processor. If you only wanted to use 2 cores, you could obviously change that to a 2 and be done with that. The main benefit here is the more cores you use, the faster OpenCV will compile. However, if you do run into an error, I would suggest running make clean followed by make using only a single core. This can help avoid errors that you're running into, but in most cases you should be able to compile in parallel without too much of a problem. So I'm going to execute this script and start off the compilation process. As you can see, it's starting to run. It could run for a good 1.5 to 2 hours. So at this point, I was just taking a step away from your computer, maybe making a cup of coffee, going for a nice long walk. And that's exactly what I'm going to do. So I'm going to catch up with you in about an hour or two once the compilation is finished, and then we'll actually install OpenCV on our system, finish doing a few more things with Python to get everything ready to go, and that'll be it. So believe it or not, you're more than halfway there. You're through the hardest part. Everything from here is quite simple. So I will see you in a couple hours. Hey, so it's been a good 2 hours, but as you can see from my output, OpenCV has been successfully compiled. So now all that's left to do is to install it. And luckily this is a really straightforward process. First command is sudo make install, which will actually install OpenCV to our system. This command will take about a minute or so to run. So I'm gonna let this run and catch back up with you once it's fully at 100%. All right, we've done the make install and one last command that we have to run, and we'll be done with the actual OpenCV building and installation. So at this point, if you've gotten to step number 5, OpenCV should now be installed in this directory, user/local/lib python 2.7 site packages. This will be slightly different if you're using Python 3, but again, I'm using Python 2.7 for this build. And if I list the contents of this directory, we should ideally see the cv2.so file, which is our actual OpenCV bindings. So as you can see, there they are, cv2.so. The last step is just to get the actual cv2.so bindings into our CV virtual environment. And that's also very simple. We're just going to change the directory to the site packages directory of the CV virtual environment and create a symbolic link between the cv2.so files. And after that, you're done. OpenCV is now fully installed on your system for Python 2.7. Little caveat to remember though, if you're installing OpenCV for Python 3, for whatever reason, the .so file comes out like this. Again, I don't know why it does that, but it's an easy fix. Just run the move command and rename it to cv.so, and then change directory to your CV virtual environment for Python 3 and symbolically link in the cv2.so files, and you're done. So that brings us to step number 6, which is the most fun part, and that's ensuring that our OpenCV install actually works. So to show you that it does work, I'm going to actually log out of my Pi first. I'm going to log back in. I'm going to source my .profile to set up my environment, access the CV virtual environment, which contains my OpenCV bindings. We'll launch Python. As you can see, I'm using Python 2.7.9, import CV2. That finishes up without an error. And then finally cv2.version. And then we have 3.0.0. So as you can see, OpenCV fully installed at this point. Everything's working as expected, and you're free to develop your own applications using Python and OpenCV together. If you run into any problems, please consult the troubleshooting section of this blog post. And again, if you're using Python 3, please remember to check this section as well for the additional added steps. So I hope you've enjoyed this tutorial. And if you want to learn more about OpenCV and computer vision, I would definitely suggest you take a look at my book, Practical Python and OpenCV, which is 100% fully compatible with the Raspberry Pi and covers topics such as face detection, object tracking in video, and handwriting recognition. It's a really cool book. Again, all examples do run on the Raspberry Pi out of the box. So be sure to take a look. Otherwise, I will see you on the Pi Image Search blog.